Hey everyone, welcome to another meeting of the Research Triangle PowerShell User Group. My name is Mike Kanakis, and it is July 5th. And tonight we are going to be talking about taming Git with PowerShell and Posh-Git. Before we get to our speaker for the evening, I'd like to welcome in my co-host. Hey Phil, how are you? What's new?
I'm doing well. New is just everything's super busy. That's just the way it goes. Work's always super busy, and so I'm glad to be here tonight.
Yeah, getting ready for PowerShell on the River this summer, right? Yeah.
We are.
Yes, we are. And so, without further ado, it's our extreme honor and pleasure to welcome in a regular of our user group. We'd like to welcome in Mr. Sean Wheeler of Microsoft PowerShell Docs team. Hey, Sean, how are you this evening?
Good.
I gave a little primer about what we're going to be talking about, but I don't know what you got in slides or intro. But for people who are not familiar with our group or who you are, what are we going to talk about and who are you? Give us a little info.
So for those who don't know me, I'm the lead documentarian for PowerShell at Microsoft. And what that means is I'm not a filmmaker, but I call myself a documentarian because I'm more than a technical writer. I'm responsible for all of the documentation for the PowerShell product itself and the commandlets and modules that ship with PowerShell. I don't do Azure PowerShell and all the other modules that Microsoft ships, but I do a lot of other things internally to support those modules and the people that own that content. So, like I said, more than just a technical writer.
And Sean, I should say that you have invested quite a bit of time into making learn.microsoft.com and the precursor docs.microsoft.com be as awesome as it can. There's been amazing improvements that have come to that website in the last 2 years. And so thank you for that. I think everybody that's watching this at home, definitely the people on this call, have browsed something you've written and have appreciated the time and effort that you've invested and the team members that work with you on those articles. So thank you very much for that. It's very helpful.
Yeah, and the community response or the feedback that you've gotten from the community about, hey, improvements that can be made, and also you advocating for the community, going, hey, we need to change this because it's just not getting the traction or people don't understand this. I think that's been a real value, and basically advocating for it. So I think that's admirable. So thank you.
Well, thanks. It's been a labor of love, and I'm lucky to have Mike Robbins and Mikey Lombardi working side by side with me. So,
and Chase previously and some of the other guys, just some really talented people.
So tonight we're going to talk about using Git and the GitHub workflow and doing this all from PowerShell. And I'll take you from the very beginnings of installing Git and so on. I've got a whole walkthrough of the Git workflow, and we'll see how far we get. I wanted to talk about rebasing because a lot of people are scared of rebasing and want to demystify that if I can. But let's just jump into it. I'm going to start by sharing my screen.
All right. And before you do that, well, you share your screen, obviously. That's fine. I was just going to say we have a number of talks in our YouTube library on Git, and we've done some previous demos. I honestly think that Sean's probably going to do the best job of this out of all the ones we've seen prior. However, this is a challenging topic for a lot of people. And so there's other presenters that have done this. And so we encourage people to go take a look at the other demos to help cover this. I was going to ask Sean, where do you think the knowledge level of person watching at home should be to kind of be able to jive with what you're going to be talking about tonight?
Well, they should be comfortable in the command line of PowerShell. But I'll be covering the Git commands that you'll use from the command line and so on from basically the beginning. So if let's first just talk about what is Git to begin with. Git is a distributed version control system. And what does that really mean? If you've ever used some of the older version control systems, or you remember the way things used to work in SharePoint way back, you would go in, you wanted to work on a document in SharePoint, you had to check it out, and then you could make changes to it. And while it was checked out, nobody else could make those changes. The way Git works is everybody has a copy of everything, and you make your changes locally, and then you submit them to merge back to the main source of truth, and it merges your changes into that central repository. And Git has a way to manage changes coming from multiple sources, multiple contributors at the same time. And if two people tried to change the same part of a file, it can flag that as a merge conflict, and then you have to figure out which change do you want to accept. But this Git and GitHub allows you to scale out your version control to thousands of people, and it is the source control tool that is used by the majority of the industry these days. So that's what we're starting with.
And it could be pretty daunting for people that are getting started with Git in the beginning, especially because the commands are not the most friendly. And so I think that's maybe a good lead in here, because some of what you're going to highlight is how you can use some of the goodness that people have come to expect in PowerShell to help make Git a little more palatable. Is that fair?
Yes.
Yeah.
And then there is a module that you'll want to install from the gallery called Posh-Git, and we'll talk about what that does for you. So if you don't have that installed, go ahead and get it installed.
I'm doing it right now.
So to get started, you go to git-scm.com/downloads, and this is where you download the Git tools itself. And I use the command line interface. The only GUI client that I use is Visual Studio Code, and I only use it for specific tasks. I don't use it for everything that it can do. And I don't like using GUI tools for Git because they hide the Git process from you. And so if you ever run into a problem, you're going to have to go to the command line and use the Git command line tools. And if you're not comfortable with that and you don't know what the GUI tool is doing behind the scenes, you're not really learning. So like I said, I do a lot of stuff from the command line. And
we were talking about
that.
Yeah, we were talking about that prior to this meeting getting started. So like VS Code can be your best friend, but can also hurt you in that regard, because it can abstract away most of what Git does. And so that's great to get started. It makes it easy. But when you have real things you need to do in Git, resolve conflicts, and like Sean was saying, you have no foundation. So you may not understand, but I think Sean is going to be preaching here to learn the command line. And then when you get past the command line and get really well schooled at it, incorporate VS Code into what you do a little bit, maybe to make yourself faster, but never lose the command line, because anytime there's a problem, you will absolutely need the command line.
Yep.
Yeah.
So you pick your operating system for the package you want to install and get that installed. I'm doing this on Windows. I don't really have Mac. I don't have a Mac at all, and I have Linux installed for WSL, but I use I use Windows for everything. I've already have this installed, so I'm not going to go through the process of downloading and installing this. The next step is you need to, once you have it installed, you need to configure it. And these are things that you only have to do once per computer. So you'll need to, you'll want to run these commands: git config global user.name and give it your first and last name. And you'll also want to set your email address. These are used whenever you submit a pull request. This information is included in your commits and in your pull request. And then if you're on a non-Windows system, you'll also want to set up the credential helper. So you want to run this git config global credential helper store. And this enables secure storage of your Git credentials, your GitHub credentials, and automatically takes care of passing those credentials, so you don't have to provide them on the command line every time. If you install the Windows package, it installs a credential manager helper, and it configures it automatically, so you don't need to do this command here. It's a totally different helper backend.
Hey, hey, Sean, I just wanted to interrupt one. So, about 4 years ago, there was some community projects, and I was lucky enough to get involved with one of them. And when I started, I had no idea how to really use Git. And so, for me, the command line was too much to start with. I just didn't understand what was going on. And so I worked with the GitHub desktop tool, the GUI client that you can download from GitHub. And that is how I was able to participate in a large repo with one of the PowerShell conference books until I learned Git enough to be confident in the command line. So that may be someone that's listening. If the command line is too challenging, you can still participate in Git and not use VS Code and see everything go away. You can do it in a GUI client like the GitHub for desktop as a way to get started if the commands are a little too challenging. But the assumption here is that everybody that's watching this probably has some experience with Git and they're comfortable with the command line. But if that's not you, a GUI tool might be a good way to get your feet wet.
Okay, so once you have Git configured on your system, and you can see here I've configured my username and email already. You'll want to install the Posh-Git module, and you want to edit your PowerShell profile and add an import statement for that. So you'll see here that Posh-Git, I have this installed and loaded in my session. So what Posh-Git does is it's a helper module for Git. It provides tab completion for Git commands. So you don't have to know all of the various Git commands, and it provides tab completion for parameter values as well. So like branch names and things like that. And the other thing that it does is it provides a customized prompt when you're in a Git repository. So for example, if I go to my PowerShell docs repository, you can see now my prompt has changed. And what it's showing me here is, well, I'll give it directory listing. So here's the PowerShell docs repository on my local system. And it's telling me I'm in the main branch. And right now, the branch is completely up to date. There are no changes or anything that need to be synchronized. And we'll see how this prompt changes over time. So I've got this set up in my environment. And I'm going to publish these instructions that you see here really as a part of the demo that I'm doing, and so you'll have access to the repo. So let's talk about the Git workflow. But before I do that, I'm going to give a plug for the PowerShell community blog. This was one of the links that I put in the chat earlier when Mark asked about code resources. So there's this blog, but this is a blog that I help manage and maintain. But the posts here are contributed by people from the community, not necessarily from Microsoft. We have a few from Microsoft, but they're not on the PowerShell team or the PowerShell docs team. And so the way we've set this up is this is all backed by a GitHub repo. So it's GitHub PowerShell /community-blog. And the way this works, the documentation that I'm showing here is how you can make a contribution. And we explain the whole Git workflow process. So I'm going to talk through this diagram, and then we're going to go do this on a real repo and walk through all the steps. But what I'm showing here with all of these steps and all the lines that you see, this is all explained down below and gives you the example commands that you would use. So, and the names of the repositories here are specific to the community blog, but you could substitute this with any open source project that you wanted to contribute to. So what we have here in GitHub is the PowerShell /community blog repository. And in order to contribute to it, the first thing you have to do is these steps with the red arrows. First, you need to fork the repository. What that does is it creates a copy of the repository in your account in GitHub. So you have a copy in the GitHub cloud. And then the next step, you need to clone that, and that makes copies your fork down to your local machine. And then the last step we need to do to get started is we need to add an upstream reference here. So Git has this concept called remotes, and upstream is the name of remote. And when you clone your fork, the name of the remote for that is called origin. So we just need to add this upstream remote that points back to the original Microsoft repository.
Just wanted to chime in and let people know that the process that Sean is detailing here, if you are participating in a project, an open source project that's public or a group project, everything he just said will be 95% of the time exactly the same.
Yeah.
So Git is an exercise in repetition. And once you get a comfort level with the commands, you can jump to different repos and different projects, and it'll essentially be the same exercise every time. Forking, setting an upstream,
forking,
doing all those,
cloning, setting your upstream. Yeah.
Yeah.
So this is the install steps for the install and configuration steps that I talked about previously. That is something you do once per machine. This step here, where you fork, clone, and create your upstream, this is something you do once per repository that you want to contribute to. And the whole purpose here is the reason why you need to create these copies here, the fork and the clone, is you don't have rights to make changes directly in our repository. So you make a copy of it in your own account, and you have full rights to do whatever you want there. And you can make the changes using the GitHub interface and never clone to your local machine. But if you want to do anything at scale, you need to clone it to your local machine and do all your work locally. And that's typically what you're going to do in a larger open source project. So these steps, the red arrows, this is you do once per repository. Now you're set up locally and you want to start making contributions. The first thing you should do every time is do a check out the main branch or whatever the default branch is. Might be main, might be master, might be something different depending on how the project is organized, and that will be documented for the project. But once you've got the main branch checked out, then you do a git pull upstream main. What that does is it copies down the latest changes from the upstream source into your local copy. And then what I usually do is immediately do a git push origin main to push those changes into my fork. That way, these three repositories all have the same state. So I'm getting ready to make a contribution, make some changes. I do my git pull upstream, and then I want to create a new working branch in my local repository. You never want to make changes directly to the default branch, main or master. You should make your changes in a working branch. That way, if you mess something up, you can always throw away your working branch and you haven't changed anything in main. That's the safest path forward.
And it's also the path that nobody follows.
Right.
Right. So if you take one thing away from this meeting, please don't commit to master all the time. Right.
Yeah.
Learn the idea of a branch. It's more work, yes, but it will save your bacon.
Yes. So the command for that is git checkout -b, and you give it a branch name for your working branch. Now you have a working branch, and you can make changes. You can add files. You can delete files. You can make changes to existing files. You do all that in your favorite code editor, VS Code, of course. And then once you've finished all that, you're ready to commit your work and use the git commit command. Excuse me. Before I can commit, I have to add them. So I use the git add -A command, and that means add all. So you can selectively add individual files if you don't want to add all of your changes to Git. But typically, you just want to add everything that you've done, and then you can commit. And so the shorthand way of doing it is git add -A for all. Once you've done that, you want to create your commit, and you want to give it a description of what you're committing, what kind of changes you're doing. This is limited to 50 characters before it wraps. Anything over 50 gets added to the comment section of the commit. So, but you want to make this meaningful. And so what you're doing here with the add and the commit is when you come in here into your new branch and start making changes, the changes you make are not being tracked and managed by Git until you add them. Once you've added them, then Git adds tracking information to its database, about those changes. And then the commit bundles those changes up into a package that you can then merge back into main.
So I have lots of questions, but I'm eagerly waiting to see what you say next to see if I need to ask the question. And so there's a question that I just answered in chat that probably fits in here, but I wanted to say, like, look, can we step back and just talk about what's happening at a very simple level, right? And correct me if I'm wrong here. When you're making changes, you're working on your local machine, and they exist only in your local machine, and so you got to get them from your local machine into the repo.
Yes.
Right. That's the git add. Git add essentially says, hey, Git, watch this file for me. Because Git is not, we're all used to OneDrive sync and just drop something in a folder and OneDrive does all the work. This is all manual. So unless you add a file, Git does not watch it. So git add is saying, watch the file for me. Correct?
Yes.
Yeah.
And we'll see this once I get into demo. That kind of information shows up in the prompt up here.
Yes.
And I'll explain what all of that means in the prompt and how you can tell what's going on with the state of your repo through each of the steps.
Okay. And so git commit is the process of saying, copy this file or this change from my machine to the repo.
Well, no, git commit. So add adds tracking information. Commit bundles all the tracked files into a package that is mergeable.
That's what I wanted to say. You said it better than me. Thank you.
Yeah. So we went here from step 1 to step 2. Step 3 was where we changed, made our changes. Step 4 was we added the changes to the tracking. And step 5 is we committed them. And so now all those changes are here in our local repo. And we're ready to, we want to get those back into the main repo. So what do we need to do? First, we need to push those into the cloud. And I can't write into the main repo because I don't have permission. So first thing I have to do is I have to push those into my fork. And so that command is git push origin and your branch name. And so and that's where these remote labels come in. So I'm telling it I'm pushing into origin. And now that branch exists here. And then I can create my pull request where I say I want to merge my branch into main on the upstream repository.
I feel like there's some context that's needed here because I completely understand what you're saying, and I'm sure everybody. I'll get to you in 1 second. I'm sure everybody who has some Git experience understands this, but for the person, the layman who's trying to understand why do I need to do all this, I think that is missed because it's assumed, right? So,
the reason is I've made all my changes locally, and I have to get them into the cloud, into GitHub.
Well, what I was going to say is that if we imagined a project like the PowerShell repo that Microsoft has, that's open source, and they allow people to make changes to those commandlets.
Right.
And so there's let's call it blessed code, production code. And then Mike wants to work on it, so Mike takes a copy. But Phil also wants to work on it. Phil may be halfway across the world. I don't know what Phil's going to do. Phil takes a copy. And so the reason you're going through all these steps is there is a predetermined way to get the changes that you want to push into the repo to be accepted. It has to be reviewed and all these steps. So this is the process to take multiple people's changes and merge them in. But when you look at them as one, as Sean is describing here, you're like, man, this is a lot of work. Why do I need to do all this? Because the assumption is other people are doing the same thing, and
other people are doing the same thing. But more than that is you don't have rights to this original repo. So you have to have a way to get your changes submitted into them. And then, yes, there's a review process. And we'll get to that in the demo. But that's the whole point here is what we started with our fork and clone was we had to make a copy in the cloud, and then we had to copy that cloud copy down to our local machine so we could do our work locally. Then we had to push our changes up into our fork, and then we could do a pull request to send them back to the base repo. And we do that for two reasons. One, we don't have permission to write directly, and two, our changes need to go through a review process. And there may be other people making changes in the same files, and so there may be some conflicts that have to be resolved before they can be merged. So that's the mechanics of this. And like I said, you'll have access to this step-by-step documentation when we're done with all of this. So let's go with a real-world example.
Before you get to that, we've had one person waiting to ask a question. So Wei, I'm not sure what you want to ask, but go for it.
Yeah, thank you. In regards to creating a fork in GitHub, like I come from the GitLab world where you can just you add yourself as a member, and then you create a branch, and then you merge yourself in. But are you saying in GitHub, if I don't have access to the repository, I've got to create a fork, merge it back in, and then remove my fork project, or how does that workflow?
You keep your fork around for as long as you're going to continue to contribute. And I think this will be clear. I'm about to demo the whole process, so hold the questions because I think they may be answered in what I'm going to show you. So first thing we need to do is, well, I'm going to show you how I organize my Git repos. You can see here I have a Git folder on my D drive, and I have all these subfolders, and I have clones of 78 different repos that I contribute to or that I monitor. So I have a lot of stuff. And for this demo, I'm going to go into my community folder where, and this is where I'm going to clone the new repo. But I need to find a open source project that I want to contribute to. And so here's an open source project. And so, Mike, this is where I'm going to need your help.
Oh,
I'm going to submit a PR here and make some changes, and I'm going to have you review the PR and merge it.
Okay, sure. Let me get logged in there. Sure. I was waiting to see what that was going to be.
I'm going to start first, like any good open source contributor, and create a new issue. And I'm going to say, add documentation for this repo.
You got to something I was going to ask you about earlier. And I don't want to interrupt you here, but the other assumed thing that we talked about was commit messages. And you said you want to make a good message. And I don't know that we did enough justice to explain what purpose the message serves.
Yeah, we'll get to that in the demo.
Okay, good. I do need all the stuff you see here.
Okay, so I've created issue number 1.
All right.
So now what do I need to do? I'm going to go back to the main page for the repo, and I need to fork this first. So you go over here to the fork button, and I have to fork this. Well, let me go back. There's this test file here, and if I wanted to make changes to it, you'll see I hover on the edit button. It says fork this repository and edit the file. So the first thing I'm going to have to do, actually, if I do this, it's going to ask me to fork, but I don't want to edit this file directly yet. I'm going to go back here to the fork, and it wants me to select an owner organization for this, and I'm a member of multiple GitHub organizations here at Microsoft, but I want this in my personal account. And I'm going to create that fork. And now I have a copy of this repo under my account. And I need to clone it to my local machine so I can make the changes. So if you click on the code button here, you see you've got some things here to help you out with cloning it. I use HTTP URLs for all of my GitHub stuff. If you have the GitHub client utility installed, you can use this command, but I'm going to show you how to do this with Git. So I'll click the copy button, and what we need to do here is git clone. You paste the URL, and now I have the NicoGad Git Primer folder. And you see when I changed into that folder, now my prompt changed, and you can see I'm in the master branch.
Because I'm lazy and I haven't switched from master to main.
Yeah. So I can run git branch and see what branches there are. I can run git remote -v, and we can see I have a remote called origin that's pointing at my fork, but I don't have the upstream remote. So now I need to do a git remote add upstream, and I'm going to go and copy this link back to the original Mike's repo, and now you can see I have both the origin and the upstream.
And so I will say that if you're getting confused with Git, it's going to be on what Sean just did. This is by far what everybody gets confused on the most, is the setting the upstream and then merging branches, which we'll talk about in a little bit. If you're working in your own repo and you don't have to fork your repo and you don't have to have an upstream, this is obviously a lot easier.
Yeah.
But if you're going to participate in someone else's repo, this would be the process.
Yeah. So remember, upstream is pointing at, in this case, Mike's repository, and origin is pointing at my copy of the repository. And I have rights to my copy, but not his. So now I need to start making changes. So going back to our process here, it's always a good habit to do the git pull upstream. So I'm going to do that. I don't have to because there's been no changes.
So just out of curiosity, I'm on, and I could show if anybody needs to see this, but I'm on the repo, and I actually don't see the fork yet.
You should.
I'm just wondering if GitHub is being slow catching up.
I see one fork. Hit refresh.
I did, but well, maybe I didn't notice that until after you started, because I thought there was one fork there already, but one fork doesn't show me who it's from. Okay.
Yeah, there's a way to get that information, but Oh, yeah.
Yeah. Thanks, Corey, for reminding me that it definitely said 0 before.
Okay. So, yeah, back to here. Like I said, I always do a git pull. Well, I make sure I'm checked out to the default branch, in this case master, and do a git pull upstream master, just to make sure that everything's in sync. Since I just forked and cloned, everything is in sync. Nothing's changed. But if you come back a week later, things may have been changed. So you want to make sure that you're working from the latest state of the upstream. If there were changes, then I would want to do a git push origin master, and that would push those changes into my fork. But as you can see, everything's up to date. So the next step here is I need to create a new branch, working branch. So I'm going to do a git checkout -b creates a new branch, and I'm going to call this. What I like to do is I use my initials. If you're working on something that has a lot of active branches, this helps you find your branches. I use my initials and I give it a name. There's some people that have these really long branch names, and you can use slashes. So you could do stuff like this. You could use dashes. I tend to use dashes, and I'll do something like add docs because that's what I'm working on. So now you can see I'm in this branch now. Posh-Git has changed my prompt, and if I do a git branch, you can see I have 2 branches, and the asterisk here says gives me the name of the branch that I'm currently in. So I have master and I have my working branch. So now what I want to do is I want to make my changes. And what I've done is I've created a bunch of content that's ready to go.
Look at this. What a pro.
I want to copy it in. And let's just take a look at what we've got here. So I'm going to open the repository here in VS Code, and I've created a README file. And so you see here I have the commands that we talked about for getting set up, a link to the download for Git itself, and some other resources that we're going to be working on. And then I copied in some generic licenses here. This is the Creative Commons license and the MIT license for code. A simple contributor guide with a code of conduct. So this would be probably another issue that needs to be filed to fill in the code of conduct here. And then I've created the documentation here. This is the same document that we've been looking at, but I've customized it for this repository, except for the graphic. I haven't changed the text on the graphic because I didn't have enough time to edit the graphic.
Okay, so I want to.
That's another issue that can be filed.
Okay, I want to queue up some questions for you that you're going to want to answer later. They don't fit here, but they came up in the chat and someone mentioned to me. So earlier, I believe it was Michael, but I'm not sure, asked about is it right to do things in a dev branch and then merge it into the main or the master? And so we had talked to him, but maybe explain that. I'm pretty sure you're going to cover that. And then they also asked, is there a point where things just get so messed up? Is there better to just blow it away and reclone the repo than trying to sort all this stuff out? So that might come up later as well. And then the last is a question that someone mentioned that is a really good point that we kind of glossed over. Is the reason you really don't want to be writing to main, because in a lot of these repositories, main commits to main trigger a software build.
Right.
Right. And so I know you got all this stuff sort of planned out, and so I didn't want to disturb you. Those are the kind of things that came up in the chat that we can discuss when they're relevant.
So for the question about working in a dev branch, so effectively this SDW add docs branch is my dev branch for this change. Some projects have a dedicated dev branch that they do all of their changes for a particular release, and they're treating it like a second master.
Mm-hmm.
And when they're ready to release, then they merge dev into main for the release. So really, it depends on how the project manages its branches. But for our purposes, you can treat this example as a dev branch.
But it's best practice to always build your own branch before whatever. So if they're going to push into there, you do a pull request back into their dev.
Right. Okay. Exactly. And in which case you would want to, before you create your branch here with this command, you would want to switch to the dev branch and then create your new branch, because you want to branch off of the dev branch, not off of main.
Got it.
And then when you do your pull request, you're targeting the dev branch for the pull request instead of targeting main. But that'll all be covered in the contributor documentation for a large project. All right, so you can see here I've made a bunch of changes. In VS Code shows that there's 6 changes pending. And I can switch over to this view, and you can see these are the files that have changed for Git. And you see here my prompt has changed, and it says there's 5 new files. Well, why is there 5 new files when VS Code says there's 6? Well, what happens is right now, Git is not tracking these files. It sees that there's new files, but the red numbers here means that these are untracked changes. So right now it only sees 5 untracked files, but there's a folder here with more files in it. So that's why it's not seeing all of the files. What this is this is the number of new files that have been added. This with the tilde is the number of files that have been changed, and this is the number of files that have been deleted. And if we do a git status, you'll see that same information. So these are the 5 files that Git sees right now. And it's telling you that these are untracked files that you need to run git add. Now I can run git add and add one. So let me do that, git add, and I'm going to add the contributing. And now if I do a git status, you'll see I have a file that's been staged or tracked. It's ready to be committed. And I have these 4 that are untracked. So now you see in green, I have 1 new file and it's being tracked. And I have these 4 that are untracked. And if I go in here, you see now I have staged changes and unstaged changes. So this is one of the areas where I use the UI in VS Code a lot. You can unstage a change. So if I click that, it's back down in my list of changes, and I go back and hit enter, and you see that my status changed. You can also click the plus button here, and it will. It's like doing a git add all, but I'm going to do a git add-a. And now you can see it found all 6 files, and they're all staged. Does that make sense?
Yep.
So these are being tracked. They're staged, and they're ready to be. These are the changes to be committed. So now I can do a git commit -m, and this is where you give it a useful name, a useful description. So add initial read me, and license, spell. README, license files, and docs. All right.
So is this the place where you've got to keep your commit messages good if you're going to push up?
You want to get them. You want to get them. They need to be brief, but they need to be meaningful. They need to describe as best you can what you're doing here.
Mm-hmm.
Because when you're looking at your Git history, you want to know when you did what. Without having, at a glance, without having to dig into the details.
Sure.
So now we go here, and you can see I have no files that are uncommitted in VS Code. I'm ready to here publish the branch, what the button does, and what that does is it pushes to my fork, but we're going to do this from the command line. So we're at this stage right here. We've committed everything, and we're ready to do this git push to origin. So now I want to do a git push origin, and this is where you get tab completion from Posh-Git for your branch names. So now I'm pushing that to my fork. And let's go look at my fork.
I have a question when you hit a break.
Go ahead.
What would have happened if you didn't state origin and you just did git push? I think that would have assumed origin, right?
Yes. Well, it may. I'm not. Short answer is I'm not sure, because the branch didn't exist on my fork yet, and so there was no tracking branch.
Okay.
And I'll show you the tracking branch here in a minute. But now you see I'm in my fork in GitHub, and it's telling me that SDW add docs had recent pushes less than a minute ago, and I can create a pull request. And if you see now, there's 2 branches here. I have, we'll switch to all branches. I have master and I have my working branch. But if we go over to you have 1 branch.
Mm-hmm.
So I want to get my changes merged into your repository. So one of the things you can do that's cool here is when you're doing this from the command line, it'll tell you how to create a pull request here. And you can click this link, which is the same as clicking this button here. So if I hold down the control key in, this is Windows Terminal, and click that link, it's going to automatically open a pull request. And so here is my commit message. This is where you want your commit message to be useful information. And then you want to describe, I'm adding the initial documentation for this repository. This PR contains default license files and contributor contributor information. There is a section of the contributor doc that needs to be updated in a future PR. All right. That's good enough for our demonstration purposes here. But remember, I created this issue over here. That was issue number 1. And so what I want to do here is I want to say fixes number 1. And you'll see that it's showing me the title of that issue right here. And so I'm going to go ahead and create my pull request. And you see it created a link here to the issue. I can click on that, and there's the issue. What it's also going to do is when this PR is merged, it will automatically close that issue.
So do you need to put that fixes inside the description, or you can put it into the
It needs to be inside the description here. And there's documentation on this in GitHub. If you go to the GitHub docs, there's documentation about how to link to issues and automatically close them. And there's several keywords here. There's fixes. There's
patch,
addresses or whatever. There's a couple different words you can use here.
Can you put it at the top where it says add initial README and then at the end fixes?
No, it has to be fixes pound number.
But can you put it up there at the top?
It can be anywhere in here.
Just
so it doesn't matter. Yeah.
Okay.
I've had mixed results with putting it in the title.
Okay.
It always works if it's in this first comment, but it can be anywhere in the body of this first comment, and it has to be in the format of, well, let's go here real quick. Docs.
Okay. No, I was just trying to do one, and then I'm just trying to understand. So cool.
Linking pull request to an issue. So here it is. So any of these words: close, closes, closed, fix, fixes, fixed, resolve. So close, fix, and resolve forms. And you put that anywhere in that first. So it's the keyword followed by pound and the number, like this: closes number 10 or fixes number 10. And you can do this across repo. So you can say fixes org/repo name pound number.
Got it.
So that's that. So now, Mike, you need to go in and review the PR and merge it.
Do you want me to show?
Unless there's something you want me to change and you want to do
no, just so that the people seeing at home can get the full picture. But okay.
So he's going to go here to my pull request, and I don't have it here, but he'll have a merge button.
Yep. So it is exactly right. There's a merge pull request button. And I'm going to click merge, and I'm just going to accept it as is because it's a good message and everything is good. So I just confirm the merge.
And so you can see now it's merged. And if we go back to the code page, now you see all of the new files that have been added. And here is the GitHub Workflow doc that I edited for this repo. So there it is. Here's the information. I went through that. Is it going to show me here? Yeah, I want to point this out. And when I had the PR screen open when I was entering this stuff, you can see that there was a place up here where it was showing what I wanted to merge to. I was merging to CompWiz 32 master from SD Wheeler. SD Wheeler branch name SDW add docs. And we could have changed that. So I could have targeted a different branch if he had one in his repo and so on. So now we're merged, and I'm done with this branch. So I'm going to do a git checkout master. And now I'll do a directory. Wait, I'm back in master, and we're in master. Where are all these files? So remember, this is my local, and master hasn't changed on my local, so I need to do a git pull upstream master. And now I have all of those changes. But if I go to my fork, which is here, we can see that I'm on the master branch. So here's my branch, my working branch. It has all the files, but my master branch doesn't have that. And it's telling me that I'm 2 commits behind. So what I need to do, and you can see I'm 2 commits behind. That's what it's telling me here with the up arrow. I need to do a git push origin master. And now I refresh, and I'm up to date. So all 3 copies are in sync now.
You could have gone the other way too, right? You could have gone from here and synced the web and then did a pull from your local to your local. You could have gone the other way, right?
Now, I would have had to merge my working branch into my local main, and that would be a different commit. So you don't want to do that.
Okay. Okay.
Yeah. And so that's the process in a nutshell. And so this is Wei Yan was asking about your fork. So you can see I still have my fork here, and you keep your fork around for as long as you're going to be a contributor to the project, so that you can continue to contribute. When you're done, if you're no longer going to contribute, then you can delete your fork and you can delete your local copy. The other thing that you can do is, so I'm gonna do this, and if I say I screwed up, I made a bunch of changes in the master branch, and I tried backing things out, and it's all messed up, and I just want to start from scratch again. I can just delete my local copy here. So let me close VS Code because it has a handle open. So now it's gone. And I can do a git clone again. And I've just copied that locally. I have to do the git remote add upstream again. And now I'm back to where I started, but with the latest stuff. Weigh in, yes, question.
Yes. No, I understand the fork, the reason why you have to contribute if it's protected. I've seen in other workflows where, for example, if you're a member of the actual repository, but you can't push to main, wouldn't that make it easier? Because in that way, you just pull down from the main repository, you pull down the repository that you're working on, and then you just create a pull request into master or main instead of having to fork and then make your changes and then push it back and then that kind of workflow. You just go into the one repository.
Yes, you could. What that ends up doing is your working branches are in that upstream database, and along with everyone else's working branches that's working that way, and branch management gets to be kind of hairy. So, let's take a look, for example, at the PowerShell source code repo. And let's look at, well, they only have 6 branches. And
I can see what you mean, though.
But yeah, but let's look at actually this one will be fun. Azure, lowercase Azure Docs PR, and this is actually the private version of it. 393 branches. Yeah. And a lot of these are release branches for different, it's for embargoed content. These are changes to the docs for things that are coming, and then when that change happens in Azure, then they'll merge this release branch into main. But yeah, this is an example where 393 branches, it gets to be a real mess. So by creating a fork, you're isolating your noise from everybody else's.
So Sean, it sounds like there's an inflection point. Right?
Yeah.
Because at my job, I manage 2 individuals. So we have 3 people committing code changes. And in that case, they're all employees. It's a private repo. It's all internal. We could just make some simple branches and merge them into main. Or we could fork. It's just extra work.
Right. But a fork is always safer.
Yeah,
I'm guessing for a private, for a public repo where you've got many different contributors, a fork does make sense because then, as you say, it cuts down the noise. But as Mike says, and in my situation, I've only got like 6 contributors or so actually adding to the repository. So it's not that, the branch management is not going to be that heavy as opposed to an international kind of open source project.
There's no one right way to do this. There's trade-offs, right? The other thing that you got to take into mind is Git is tracking all of these changes in its database for all of those branches, and the Git database can get large and in a large repo. So by having those changes be in a fork, you're only committing the finished change made by the pull request in the main repo. So you don't have all of those changes in your dev branches part of the repo history. I guess, so there's less overhead in the database, and there's less churn in the database. But it's all a trade-off. There's a point where it gets too big and you want to do forks, but if it's small enough, it doesn't matter.
And the other thing here that I noticed earlier when you were demoing this is that like the main branch in the upstream repo is very much like the concept of a golden image,
Right.
right? And only very safe, understood changes make it into the golden image. And so this is a way for you to allow people to work into it and not pollute the top. And by the forks, force them to figure out all their crap before it comes up to you, right? And so, because if you're just doing branches directly and people are not confident in what they're doing and they make mistakes or you have a lot of collisions, you have to sort that out. That's all stuff that potentially can pollute the master in the main repo. And the forks basically become that buffer zone. And so, yes, it's more work for the people that have to do the forking and they have to understand what to do, but it's the protection layer to the main repo that is probably considered production code.
Yeah.
So can I ask a different question slightly about, code and then like almost, I guess, build stuff? And so in a normal world, like if you're building and you're keeping your code, I think the Git has all the code itself, but then the artifacts, I think that's the proper term for the, hey, it's going to build something, it's going to create some zip files and do all that kind of stuff. That's not something you check back in, right? Like, how does that kind of organize, or how do organize companies trying to organize that process? And like,
yeah, so if you have a build pipeline, you're either doing that with GitHub Actions or you've linked up Azure DevOps pipelines to your repository, and you're doing that in Azure pipelines. The artifacts are published to GitHub in a different space. They're not checked into the repository, but they're associated with the repository in the artifacts. So when you do, if we go to
like in that MD file, you put the image, or like where is that image of that screenshot? And like,
oh, it's right here.
But so is it kind of good practice to put stuff there, or is it like, could it get too bloated in which it, other things happen?
No, I mean the image file here is not an artifact of the build. It is content. You want it checked in, but the like if you were to do a release, it would show up over here. So let's go to again the PowerShell repo.
Sean,
you can see
if I could comment, just the concept that what you're talking about, Phil, is a project, and the repo is a part of the project, but there's other areas other than the repo that are part of the project. So the artifact is essentially a parallel folder next to the repo.
Yeah. So if you look at this, so here's the releases for PowerShell. You can see all of the releases here. Here's the latest one, and you go down here to the release assets. These are artifacts of the build, and they are part of what's published for a GitHub release. A GitHub release is a different data structure in GitHub for tracking this information. And if we hover over this, you can see the URL down at the bottom here is GitHub/PowerShell/PowerShell, which is the PowerShell repo /releases/download, and so on. So it's not part of it's not checked into the source tree that's managed in the version control database, but it's checked in as a release that is tagged by name. So it contains all of the assets for this release version.
So it's kind of separate from that, and you wouldn't check in those assets at that point. So if you have a process to zip all these files up for packaging, like in your build process, but then that's something you'd want to forcibly exclude from your Git code.
Yeah, you're not checking it into the code tree. You're checking it into the release.
Got it.
And different Git servers handle releases slightly differently. So GitLab or Bitbucket or whatever, they're going to have similar concepts, but it's the implementation might be different.
Got it.
But yeah, these assets that it builds are not part of the version control data. They're part of, and so they're not, when I clone the repo, I don't get these assets, right?
Mm-hmm. Yeah. I think one of the challenges I had is when I was tuning this and I was trying to like use it, I was bringing a bunch of raw data, and that was raw data of like hundreds of megs, and then I started hitting like size boundaries because I was including more than I should have in the code itself. But I was like, well, I'm gonna make this folder an entire Git repository with all the assets and all the other pieces, be it binary files, be it zip files, be it large XML. And that was the wrong thing, or at least that's I discovered. And like, that's
well, and there's in your .github folder in your repo, there's a oh no, it's in the root. There's a .git ignore where you can say you can have files in your repository that like my local repository. This is the .git ignore is cloned down to my machine.
Mm-hmm.
But if I have any of these files or folders in my local copy, they won't get checked into version control. They'll be ignored by Git.
On your local side. And so
it won't ever end up in GitHub because of that. All right. Go ahead.
No, I think the way that I understood it, and I may be wrong, but when you put any kind of file in the source control, Git actually keeps a copy of it somewhere in its database, I believe. And so when you start to add very
tracked and committed, yes.
Yes, that's right. And so what happens is that when you have very large files, then that adds itself to the actual database, and that can prove problematic because you're making copies with copies with copies.
Right.
That can add problems in there.
Right. And actually, the way Git works is it doesn't track whole files, it tracks differences. Now, the first time you add a file, the whole file is a difference. Mm-hmm. So the blob that gets stored in its database is the whole file. When you make a change to that file and add that, it only tracks the changes. And it tracks the history, and so it can rebuild the file at any point in time by checking out the original and replaying the differences up to the point that you want. So it's always possible to get back something you've done in Git if you just know enough of the right magical incantations to get there. And Git also compresses the file data and difference data when it adds it to the database. So if you're adding something like a video file, that video file is already compressed. It's not compressible again. So it's going to add bloat to your Git database. And if you add changes, it doesn't have a way to really diff that. If you added a new version of the same video file, it's going to end up storing the whole video file again because it has no way to do a diff on that.
Okay, cool.
And just a comment here that kind of leads to some of that replaying of the files. I'm going back to something earlier Sean talked about that we just didn't cover in a lot of detail, is one of the reasons to have good commit messages, because you're trying to be able to go back and figure out from the commit messages what the concept or the purpose of what those file changes were in that package of pushed files. And so, when someone goes fix 1, fix 2, fix 3, what ends up happening is you can't rely on the messages. Now you have to go and read the individual scripts or files to figure out what actually was changed. Commit messages solves that. I fixed a bug in this line or something like that.
Right. Now, these aren't the greatest commit messages you see in my history.
Fix that.
Yeah.
We're all guilty.
But this is, I mean, this has meaning to us. Like, for example, that is the issue number that I'm working on. And so I can go look up the issue and see what this was about. So I have enough information here to understand this commit history. So yeah, that's why you want good commit messages. So so the next thing we want to do is we want to clean up our branches. So if I do a git branch here and list my branches, you can see, oh, that's right. I deleted my repo and this is a bad example. Where do I have? Let me go to. So here I have a branch that's been merged and I don't need it anymore. And if I do let me do a git branch -v, I can see what commit ID these are at. And I can, if I do a -r, that shows me the remote branches. So you can see, so Git has this concept of the remote tracking branch. So this is the remote tracking branch for this local branch. And so this reference here links that to my origin. So Mike, you asked, couldn't you just do a git push and it would push to your origin?
Mhm.
Well, there's no tracking branch yet. So I need to push it to my origin, and then it creates this tracking branch.
Okay.
And then if I make more changes and I want to push again, I can just do git push, and it knows I'm on that branch, and there's an associated tracking branch, so it knows where to push it. So what we want to do is I want to delete the local branch and the tracking branch, but I also want to here, if we go look at the branches up here, I want to clean up my branches, and I want to get rid of, actually, this branch has been deleted from the upstream. That's interesting. But we can show you what to do here. So I want to do a, what we can do if there were, if the branch, oh, sorry, not the upstream. I want to be on my fork. So there, you see the branch exists in my fork. I need to delete it from my fork. I need to delete it from my local, and I want to delete the tracking branch. So the first thing I do is I do git push origin --delete and the name of the branch. Oh, sorry. Did I put that on here? And yeah. So that, if we do a git branch now, you see it deleted the tracking branch and it deleted the local branch. didn't delete the local branch. It deleted the tracking branch, but if I go over here and I refresh, it deleted it from my fork. So that command, the git push origin delete in the branch name, that cleans up the tracking branch and deletes it from your fork. Now I need to remove it from my local. And you can see now it's gone. So that's how you maintain your branch hygiene. You should always clean up. After you've merged your branches, you should clean those up. So that's the basics. You're working this workflow just over and over again.
So one of the questions would just be about like any other tips for like fixing problems. Like, we kind of talked before is like at what you kind of said, if things screw up, sometimes it's just as easy to just delete the entire local and then re-pull again. Is it, keeping yourself in sync, rebasing, or where does that come along?
Well, yeah. So if you work this workflow religiously, so you're always starting from main or master, you do a git pull upstream main, and you're keeping things in sync as you're working, you should be in good shape.
Okay.
You shouldn't get into trouble. What happens is, there could be other people working at the same time you are, and you may be working for several days on a change, and then you want to go merge it, but main has moved on from where you started. So that's a case where you will want to rebase. And rebasing is not that difficult once you understand what it's doing. And to help us understand what it's doing is this website here, Git School and GitHub.io, has this visualizing Git environment you can play with that kind of shows you what's going on here. And so let's take a look at how Rebase works. First off, let's look at what's going on here. There's several labels that Git uses to track branch names. And you can see the orange one here, that's the name of the branch, and that's a label. And we have a feature branch called feature. And you can see the gray ones here, there's your tracking branch reference. And then head is a special pointer that Git maintains. And head always points to the currently active commit in your branch, whatever branch you're on. And so what we have here is that we have a local repository and we have a remote repository, like in GitHub. And you can see here the feature branch is one commit ahead. So the first thing we want to do is we want to get that in sync. We need to bring this down. So I'm going to do a git pull origin. And so now I've pulled that down, and you can see our feature branch has the same commit numbers on it. And so features pointing to the same commit. And say we do some more work locally here. I'm going to do a git commit, make some changes, run git commit. And I'll do this a couple times, and now I've moved the branch ahead. And I might want to do a git push origin, push those changes up. That's fine. we're back in sync. But meanwhile, on master, other people have been doing work, and there's new commits. And I'm ready to. I want to get things in sync. I'm going to push origin here. Get both the local and remote in sync. But I want, I forked from master back here at this first commit. My feature branch forked off from here. And I want it to be forked off of this commit instead. Because there may be conflicts here, and I also don't want a messy commit graph, because you get all of these parallel branches, and it can be a real nightmare if you ever have to go back in time and retrieve stuff. So I want to rebase. So what we're going to do here is I'm going to do a git checkout feature branch. And so now you see head moved. It was pointing at master, and now it's pointing at the feature branch. So I'm on the feature branch. I want to do git rebase, but I want to rebase on master. So what's going to happen is it's going to take all of my commits and tack them on to the end of this. And what it's doing is it's replaying all of my changes to the master branch starting from here. And it actually ends up replaying these changes one commit at a time, because there may be a merge conflict at any point along the way. So it replays this one. If there's no merge conflicts, then it replays this one. If you have merge conflicts here, you'll have an opportunity to resolve the merge conflict and then continue the rebase, and it replays the next one, and so on. And so now,
so let me pause there. What I think took me a while to understand is that you said when there's a merge conflict, effectively you're going to then create a new commit that is the resolution to that conflict. Correct?
Yeah, technically that's what happens. So you'll go in and you'll see the merge conflict information in the file, and you have to choose which block you want. Do you want the original or the incoming change?
Then you have to push it back.
Yeah, VS Code has a nice user interface to help you choose which ones you want to do. You make your changes and you commit the version that you want to resolve the merge conflict, and it's that commit that gets put in this chain, and then it goes to the next one and replays the changes. And finally, when you've resolved all the conflicts, you end up with a new commit that you're starting from.
Oh, so it's a new commit that replaces the merged one or the resulting one.
And if you see here, these SHAs, these SHA commit IDs have changed over here. You actually have new commit IDs. So this is getting deep into the weeds of the internal workings of the database, but this is actually what happens. But that's all that a rebase is doing, is that you're saying I forked from here, but I don't want to make that my base. I want to rebase to a new point in time, and then it replays those changes, and now we're in sync. So now I want to do a git push feature. Git push origin feature. And in this UI, it just wants me to do a git push or what? Push rejected. Oh, I need to do a force. That's right. Whenever you rebase, you need to do a force that says, I don't care what state you have, take the new state.
Mm-hmm. Got it.
So I force pushed feature, and now my local and my remote are in sync. And that's how a rebase works.
Cool.
And I think that's pretty much it. And I know we're deep on time, so I think I'll end here and take any last questions.
Jeremy was asking why head didn't move to the end.
Top.
Top.
So in origin, head didn't move because it was head was pointing to master, but let me back out. But on my local, it's here. Now, if I do a git checkout master, you'll see head move. So it's just, it's the context. If I was somehow in origin making changes, they would be making them to master because that's where head is pointed.
Mm-hmm.
So that would be effectively the same as going into your repo here and choosing, which branch you want, and then making changes. So this switches head to live. And now if I were to go in here and edit this file, I'm editing in live. Head is pointing to live here on GitHub. So head, where's my visualizing Git? There it is. Head, the reference that head is pointing to is local to the repository. It's not something that changes with the branch.
So let me give a little disclaimer here. First of all, I think we need to say thank you. It's a marvelous job in trying to explain an extremely complex topic. So kudos to you for the simple explanation that you did to try to explain a complex topic. However, Sean covered an awful lot in 90 minutes. And if you're watching this video and you haven't grasped it all, you're not alone. This is a process that you need to do repetitively to get to the comfort level that Sean is at with these commands. Sean's probably made tens of thousands of commits over the years. And so the first time through, it seems like Latin, and it's very hard to comprehend. And so that's the reason for test repos and playing and practicing. But the process that Sean went through here is essentially the process that you would deal with any repo that's public that you want to participate in. So once you start to get that process down, you won't go to another company and then realize, oh, they do it a completely different way. That should be the process that everybody follows.
Yep, this is every company is going to use some version of this process. There might be minor specific differences, and they may have certain styles for branch names and how branches are managed and used and so on. But the concept's the same. You're setting up this triangle with the base repo, your personal fork, your local copy, and you're just trying to keep everything in sync in that triangle.
All right. So I don't think we have any other questions in the chat that we didn't cover. So we're probably at a good breaking point here. So I definitely want to, again, say thank you to Sean for taking the time to explain this concept. We've done this a few times. It's always a challenging topic. Sean, I think you've probably done the best example of this I've ever seen. Excuse me. So thank you for that. It was really eye-opening to see it step by step. I thought it went really well. Phil, any closing comments before we wrap it up?
No, other than I love this little
The visual
UI thingy. You know,
Yeah.
I don't think I've ever seen it, done so well. So thanks for that. That's a great tip.
Yeah, and I put that in a link to that in the README in the Nico Dad Git Primer repo, so you can get to it from there. And
I'm busy playing with it. It really makes it sense that like things are moving around for me. So I really appreciate it.
Yeah, it made a big difference when I was trying to figure out Rebase. Rebase scared me, and now it doesn't.
Mm-hmm.
And there's two reasons you do a Rebase. One, and mostly it should be to refresh your branch, and when you've been working on it a long time, and the branch you forked from has moved on since you started. But the other thing is you can squash commits. So you may a common practice is what people call commit frequently. So you make a change and you commit it. You make another change and you commit it, and that way you can always back out to a previous change, and you just keep doing this until you get it in the state you want. So you may have a dozen commits in your history, and if you were to push that to your fork and submit a PR, then all of that commit history goes with it. And you want to be a good citizen, good open source citizen. You don't want to junk up the commit history in your PR. So before you push to your fork, you can do a interactive rebase. So you do a git rebase against main or master -I for interactive, and it'll open VS Code for you and list all of the commits, and you can change the. You'll see beside each commit what it's going to do, and it's either you can change it to say squash instead of I forget what the default is.
Pick.
Yeah, I think it's pick. But anyway, you change it to squash, and what happens is all of those commits get squashed into one commit. And so when you go to submit your PR, it's a clean PR. It looks like you only have one commit. And you don't have all of this noisy commit history where you're trying things that didn't work, so you made other changes and reverted back, and you have this, all these noisy commits. You don't need that in the history.
Heard it explained as devs would say, I don't want someone to see all the dumb mistakes I made when I was figuring this out.
Right.
So I rebase to squash it down to one thing, and they don't see that I was trying this and trying that and trying this, so. And Phil, I'm going to say it. My name is Mike, and I've gummed up some public repos with bad commits. All right. I think this was a huge success. And if you're struggling at home, that's why we record these, so you can go back and watch them. And if you're watching on YouTube, we'd love for you to come and join us in person so you can ask questions and participate and find out the information you're looking for. So if you'd like to come and join us, you can visit us at rtpsug.com, or on Meetup, you can look for Research Triangle PowerShell User Group. If you're all watching on YouTube, check out the rest of the videos on the channel. Give us a like and subscribe. We'd love to have you keep up on what we're doing. We want to say thank you to Sean Wheeler for doing a masterful job of explaining a truly complex topic tonight. We hope you all enjoyed this. We're going to wrap it up here. I'm going to say goodnight to everyone, and we'll see you next time.
Thank you.